Hey, I'm Brian Beeler, and thanks for joining us on the podcast. We're lucky enough to have a live meeting today and a live stream later today, so this will be interesting. I've got Dave Demlow, who's with Scale Computing. You are the, according to your profile, VP of Product Strategy, which sounds entertaining.
It's a fun job, yes. Yeah.
So for those that don't know, I mean, Scale's been around a while, but not everyone knows you, which is shocking, I'm sure, to the marketing department. Yeah. But what a reminder, a refresher, what's Scale do?
Scale is one of the market leaders in hyperconvergence, so integrating, fully integrated compute platforms with storage, with automation that lets you run applications and not have to care and feed for your infrastructure. And so, we started off really targeting kind of small mid-market companies that didn't have an army of IT people to go and learn to cobble storage together with servers, with virtualization. We've expanded to enterprise customers, often in what we call distributed enterprise or now edge computing environments. Right. So we have customers with thousands of locations that are running HC3 clusters, centrally managing those, and retail environments, things like that, where there's no IT people showing up every day to check things out and keep the IT going. And
so, what's the timeline? Help me with that, because VMware, everyone knows them, and vSAN, and sort of that trajectory, which really brought, I think, HCI into the mainstream consciousness or conversation. Now, and I know you guys have been around a while, so I'm just trying to map out like how long you've been in the HCI business relative to Nutanix and vSAN and a lot of these other startups.
Well, I mean, we were one of the original ones, and actually, I'll probably botch the year, but so I've been with the company almost 10 years. For the first couple of years, we had just the storage stack and did actually sell as a scale-out SAN or NAS. Then layered on the virtualization to that, kind of built the management infrastructure. So I'm gonna say, and I may be off by a year, I mean 2014 maybe what we released, and of all places we did release a KVM hypervisor based system at VMworld. Got a little bit of attention for that there, but
briefly
yes.
Have you been to another VMworld since then?
Just as an attendee, so.
Keeping an eye on things.
Exactly,
right Yeah, that's good. And I actually think I remember that launch. I mean, the cool thing about that time, it was 6 years ago. It's not like it's been eons, but the whole emergence of software defined, like that's when all that stuff was really popping, and I feel like businesses were more willing to explore outside the boundaries of the traditional infrastructure players, which obviously was a good upswing for your business.
Yes,
yeah.
And many back then, many of our customers were actually first-time virtualizers. They were taking 5, 7, 10-year-old boxes that with applications that nobody could rebuild or construct, and how do I migrate those onto a highly available, maintainable platform? That wasn't exclusively, but we were amazed at the number of this is their first time virtualization. They're not familiar with VMware. They have no allegiance to that. They definitely didn't want to pay the licensing fees for VMware or send their administrators to training to learn how to manage a SAN and so that, and we do a quick demo, show them how easy it is to migrate their stuff, spin up new applications, and the rest of the story is history.
Well, I think that was always the concern with KVM, right? Is that how do you make it pretty? How do you make it usable outside of just the nerd audience of people that are comfortable in CLI? Because for HCI, I think you have to.
Exactly.
Because you're talking about edge deployments where you might have a guy, that administers laptops or administers nothing at all, and still has to do something with these systems.
Exactly. Yes.
So talk about that a little bit, about your effort that went into a GUI to UI to management. What else were you guys worried about in the early days?
Yeah. Well, the main thing was really figuring out how to create this autonomous Linux cluster. I mean, under the hood, we're using a Linux operating system. We're using KVM as the hypervisor. But Linux doesn't, no operating system just inherently clusters itself together and says, I'm going to be okay if part of the system fails. So
it would be easier if it did, though.
It would be easier. It would be almost magical. So that was really, one of the hard pieces was figuring out how do you manage, from monitoring, all the different hardware components, disk drive, different kinds of errors. We did build our own proprietary storage stack. We did look at everything that was out there, open source at the time. For a brief early stint, we actually used IBM GPFS as a distributed file system layer, determined that was insufficient, and we really needed a purpose-built virtualization specific storage layer, one that we could integrate into the Linux operating system. So not as a virtual storage appliance, not just take some iSCSI or NFS code and cobble it together. So we did build our own ground up block storage layer. So our virtual machines live in a distributed block storage engine that's distributed across the nodes. It's all our IP that manages the redundancy, the recovery. There's no, like I said, there's no file system under the hood, no POSIX locking semantics to, work around or deal with. But it let us create a very, very efficient and, efficient from a resource standpoint, efficient from a performance standpoint, hyperconvergent stack that scales to very high end and scales very small into some of these edge appliances like we're talking about today. You couldn't take a VMware system with a bloated VSA and get it to run in an 8 gig of RAM NUC and do anything of value.
Right.
Yeah,
so you guys are a little weird, right?
Okay. We'll take it.
So you're doing these things on the NUC, so we're going to get to that.
Yeah.
And we're doing a live stream after this afternoon where you're going to demo. I'm going to ask questions, and you're going to demo these things, and that's really cool. You've got a big presence, or at least a substantial presence in Indianapolis, which is kind of weird, right? You came...
Silicon Prairie, there you go.
Yeah, right. You came down from Indy for this. We're in Cincinnati, so that's great. But you do have Bay Area people. You do have people in Texas. I know in these days everyone's virtual.
Right.
But it feels like, though, honestly, like that you guys are willing to take chances where just because it could run on a NUC doesn't mean anyone, many would regularly productize.
Oh, exactly. Yes. Yeah, and we had the code running on a NUC for many, many, many years before, and showed a few people who begged us to give it to them.
Really?
Before we finally did. And we had it running for a very long time until we were convinced that there was market demand, that was filling a market need, that we could provide a good appliance-like experience. I mean, that's one of the things that people love about scale, and we do sell some software only, but for the most part, we sell a fully integrated appliance. It comes out of the box. There's nothing to, you're not putting cards or memory sticks in. You plug it into a couple of cables and type in IP addresses, and they find and cluster themselves together, and you're off to the races. And then we wrap that up with very high-touch support out of Indianapolis. So whenever you call support, you're going to get somebody in Indianapolis, 24/7, 365, that knows the product, hands-on, and that's also a key part of our solution is that very high-value, high-touch support.
Gosh, Indy's a nice town. I haven't been for a while. I've got some family over there. But last summer, maybe the one before, family went over. We stayed at that cluster of hotels. There's like 4 of them right next to the minor league ball stadium.
Oh, yeah.
There's a bunch.
Marriott.
So we stayed there. It was great.
Yeah, our offices are just a couple blocks from there.
Okay, so we went over. We saw a minor league game, which was cool because everyone's there for the fun.
It's a fun town.
And then they had fireworks. We didn't even know there were fireworks after. Then we went to the American Indy Museum. I can't remember the name of it. Right across the street. Yeah. That was cool. I mean, there's a lot of cool towns that in the Midwest that are worth exploring. And, I'm glad to see you guys making that happen in Indy. That's fun.
Yeah, great.
So next time I'm over, we'll
come on, stop by.
Stop by.
Yeah.
All right, so
go to a race once there's a race.
Ooh, yeah, right. I'm an F1 guy, but I do appreciate motor racing of all kinds. So
cool.
I never saw F1 when they were at Indy. They were there for a couple of years.
6 years or 5 years, something like that.
Yeah, but I have been down to Austin. That's a nice track.
Awesome.
They sadly will not be back this year. Anyway, all right. So we talked NUC. You teased it. Tell me about this. It's the standard NUC form factor, the 4x4 inch thing. I think you're just running one drive in there. Just tell me a little bit about the hardware and what you're doing there.
Sure, yeah. So the HE 150 is what we branded it as. So it's sold as an appliance. Yeah, we'll demonstrate it later.
Yep.
We did hold out and release this in conjunction with the new NUC 10 platform. So it's latest CPUs and so forth. This was really our first appliance version of this edge kind of appliance. So we do have other customers that are running this exact platform. We have customers that are running similar platforms. When we announced this, we actually mentioned running on other Lenovo hardware. I heard on one of your podcasts you talked about the Nano, and we've actually run and demonstrated.
Oh, the Nanos are cool too.
The software, yeah, they're cool. The Nano IoT with 8 gig of RAM, there's got a very special use case for that. But we've actually demonstrated that and can run on that, and actually did some cool things. We connected them together for a cluster using the Thunderbolt layer, and then for production LAN use the Wi-Fi connection. So you can stick them up on a wall in a cluster.
Well, those are cool too because they've got the LTE option. So if you're really edge, there's
any of these. I mean, we take the standard NUC chassis, but you can buy these as a lower level baseboard and put it into a fanless sealed chassis. That's one of the reasons we kind of central. Converged around the Intel NUC platform is all the flexibility, the ecosystem, the availability, the hardware, long life, and it's a well built, reliable platform for what it does. And for cases where you need high availability, a lot of people think, oh, this is a PC, this is this. Cluster 3 of them together, and with a system that just basically makes it look like it's one big PC, and if one thing fails or goes down, or you pull the power plug or whatever, your applications just resume running. You've got full data resiliency across those.
And we talked before, you're running the NVMe drive in these for everything. So each one's got one drive.
In this configuration, and there'll be others that come out, but we went, we kind of wanted to go to about the extreme smallest, simplest. So a single NVMe drive that hosts our operating system and also stores all your virtual machine data. We go as low as 250 gig NVMe up to 2 terabytes, and we're testing the 4 terabyte versions right now. Those will be available pretty quickly. So you cluster those together, even with a software RAID 10, you've got a reasonable storage capacity. And a lot of these edge applications are just kind of gateways, appliances, things like that don't need a lot of storage. So we have a good range of storage available.
Right. And you can run these, I mean, we're talking about clusters mostly because that's the same thing to do, but you can run just one if you want.
You can run, we offer all of our systems in a single node system, and in most cases, if it's a single node 1U rack system with 4 drives, we'll do software RAID 10. Here on a single drive, you got one copy of the data, so the expectation is that you're protecting that data or you don't care. So, you can use our built-in replication to replicate those up to another HC3 system. It doesn't have to be a cluster. It could be in the cloud. It could be, all sorts of different options. We have had customers where their use case is really a disposable edge cache. So they're running maybe a caching filer system. And you know what? If this whole thing goes down, it's fine. Our architects can still get to their plans. It just takes a hop to the corporate data center or to the cloud. It takes a little longer. We'll send them a new one out. They'll plug it in. They'll just get lower response time. We have worked with customers with that kind of an edge application where it's just it's disposable data. You can run a single node configuration. The typical high availability configuration would be 3 nodes. What I'll show in the demo is, and I don't know if this will stick or marketing will allow it to stick, but I'll show you kind of a 2.5 node cluster. It's 3 NUC devices. 2.5 nodes. It's 3 NUC devices.
We're going to cut one in half or something?
Maybe. That'd be fun. One of them is a very lightweight, inexpensive. So it's, 2 of them are i7s with 64 gig of RAM. They're running, capable of running databases, whatever you need. Those also have 2 terabyte storage. The third one is really just kind of a tiebreaker quorum, so that you have cluster sanity.
Witness,
if one goes down, it's your witness, right? It's a cheap witness, and unlike kind of a dumb witness, this gives you the ability, if one of the primary one goes down, any new data we can still write 2 copies. So even if one of these things is dead and somebody's going to show up with a replacement tomorrow, any new data you change or create in that period, this my tiebreaker here, I have a 250 gig NVMe, so that's plenty for most app. You can run a couple days with full redundancy on that. So kind of a 2.5 node cluster and very cost effective.
So we're talking 1 node, 2.5 node, 3 node. What's the biggest one you've sold of these? Because I can't quite wrap my head around why you would need 8 or 10 of them, but you could conceivably, I guess.
You could. I don't know the actual biggest one. I'm gonna guess 5, and don't hold me to that. 4 is also a very, very common configuration, and I'll tell you why. I mean, so 3 gives you full redundancy. You do full rolling upgrades. Your applications move around magically whenever there's any software update that we need to apply. If one of the systems goes down, it's fine. Everything's still running, and we give you all sorts of alerts if there's insufficient storage or compute capacity to handle that failure. However, now you're in this kind of degraded state. You're keeping 2 copies of everything, so on and so forth. If you go to that extra 4th node, if you have a service where you're going to show up in the next day or 2 and somebody's going to replace that NUC, 3 nodes is fine. A lot of these sites that we're selling to, they don't want to send anybody right away. It's like, can we wait a month? Can we wait?
How long can we
So in that case, the cost of adding the 4th NUC that kind of sits there, and when it fails, when one of the 4 fails, you literally do just evict the one out. You say this 3rd node's ever going to come back. Now you're down to a normal 3 node cluster. Where normally we don't want, if you had 3 nodes, one's down, you wouldn't want to evict that copy there. So,
right.
But you can still run with the 2 nodes up.
So tell me about administration. Obviously, it's relatively easy on site, and we're going to go through the whole UI and the demo, and it's easy for remote too. If home office is administering 20 or 30 retail sites or whatever, you can probe into those and manage.
Yeah. So it's all web manageable. I mean, again, the system itself is designed to be autonomous on site. So once you get it up and running, it kind of does its own thing, corrects you, and tells you when you needs a human attention. And for a small number of sites, we do have built into the UI, which I'll show later. Each of these clusters can have remote connections to other clusters. So on the demo, I'll show we brought one of the single nodes that I had at home and powered it up. There's 2 others we brought but didn't plug in, and you'll actually see that, hey, sites, I think I have them, Charlotte and Napa are down. So that's the kind of view an administrator would get. As you get larger and larger, we also have full API. We offer Ansible integration for our large scale customers who are doing hundreds, thousands of sites. They have access to what we haven't named it yet, but we just refer to it as the Edge portal. But it's basically a centralized phone home management system that all of these report back to. It can also actually push out their Ansible playbooks, kind of like Ansible Tower. So we have actually demonstrated and are rolling out capabilities for full zero-touch configuration, where the goal is basically, your central data center, it configures, okay, I'm going to deploy these 10 new retail sites. When they come up, when these HE150 NUCs power on, they phone home, they get their IP address configuration, they say, hey, I'm here, they cluster themselves, Ansible scripts get run to download whatever applications, deploy, configure, and so forth, to where you could truly have true end-to-end deployment of multiple sites.
That's cool. Yeah. So one of the things that scares me about edge deployments is not so much management, but incompetence. Unplugging it or disgruntled employees stealing one, which is suboptimal. Yeah. I'm sure someone must make by now, since NUCs have been out there for so many years, like little enclosures. Are there little like secure devices? How do you? Yeah,
there's all types. I mean, a lot of customers do. You can rack mount. 3 of these go really nice in a 1U rack mount cage. If you have 10, you can do them on the side, but most of them. They can be rack mounted. They can be DIN rail mounted. So you have like the Visa mount. You can put them, slide them on a DIN rail, lock them up, hang them up in the ceiling or whatnot. There's a lot of different options for it. They have the Kensington locks on there, like a laptop.
Yeah, so harder to steal.
You can take a hammer, but it's like.
You'd have to really want to manage it. But so if one of these, because it's so small, goes missing, are you worried about data protection? What do you do there in terms of making sure rogue people don't access the device?
Well, we would obviously recommend physical security in all cases. So lock them down and so forth. In a cluster configuration, any one of these systems is useless. For a virtual machine, regardless of which node it was running on, its data is always wide striped across all the different nodes, all the different drives available. So if you had one, you at least would have very incomplete data and no file system to sit there. It'd be pretty impressive for somebody to get much of anything off there. There is obviously encryption available where you can encrypt application layer and guest and so forth.
Okay. So as you're finding these going out into the edge, I mean, we talked about a lot of the typical use cases, retail, small office, distributed office, whatever. What else is there? Can these handle surveillance and some of those higher touch workloads? Like, what else have you done with these things?
And that's been. The initial applications, a lot of them were in retail, so you'd have point of sale, environmental controls, all sorts of security, the access control locks, things like that. We did find customers running video surveillance. Usually, the biggest challenge with video surveillance on these might just be the capacity. If you're doing 10, 20, 30 cameras, keeping data for 7 days, that's probably totally fine. If you are, we need to keep this for your casino, and you need to keep it for
maybe not
7 years,
right?
Yeah, and 1,000 cameras, not there. However, video is an interesting one where most of the video surveillance have their own archiving function. So keeping 7 days on here, hot data, and then archiving it off to a NAS or to cloud storage would be capable.
So you could do something like that through Milestone. Will they enable that, or
not? They don't go directly to cloud, actually. So when I did some Milestone testing on this particular cluster. Milestone has a simulator. I simulated 54 megabit cameras. I archived the data 7 days on the local cluster storage. I then actually had it archived to what it thought was just a file share, which was a VM running on the system that was actually backed by Azure File Sync, if you're familiar with that. So, and I had to do cloud tiering. So it would, like, as soon as it would move there, it would stay on that for a day, and then it would just get stubbed and removed and moved up to Azure File Storage, and that'll support up to 100 terabytes per volume.
Well, you talked about replication. Can these little dudes just sync back or automatically tier data back to a data center that's running a larger HC3 environment?
It wouldn't be tiered back, but they can do replication for redundancy. Okay. Yeah, we haven't done cross-cluster tiering at the Scribe storage layer.
Right.
But many applications could do that, like in a video surveillance type of scenario, or an analytics where you're doing the analytics on-prem and shipping the data back to corporate data center or public cloud.
It's probably early, but with the big NUC that's got like the GPU in it and that kind of stuff, that's kind of neat though, because one of the popular edge use cases that gets talked about is inferencing and AI and a lot of these other things that can take advantage of a GPU or an FPGA or whatever. I don't know how much you guys have thought about that, or if your customers are pushing you there yet, but that's kind of interesting.
Yeah, we've definitely thought about them. We have them. I think we have all of the various NUC systems in the lab, at least looking at the potential. One of the things, and even the HE150, I would say was interesting. So I said how much we stress our appliance business, but we also do. I've kind of dropped. We have very many large customers that we work with, and when we're in the selling process and it's like, oh, you need something that's this physical form factor and this, we are x86 hardware. We do certify as an appliance, but we can custom certify whatever a particular customer needs. I mean, if they're going to do it at 100 sites or thousands of sites, and so that's very common. And that was actually kind of what the NUC HE150 came out of. And in this case, we built it, saw the use case. We had somebody running this in production in a grocery store. They were thrilled with it, wanted more, and it's like, well, okay, if we're going to do this for real, we'll appliance-size it, we'll offer it to everybody, and we saw a bunch of use cases not only for edge but for kind of those small robo environments. A lot of the cases, interestingly too, and this is one I would say maybe we didn't expect, a lot of interest from managed service providers, and that's been a big emphasis of ours in terms of partnerships. Kind of given our original focus on SMB, and managed services are now kind of the preferred way that SMBs prefer to buy. But partners are seeing this as an opportunity to go in and replace single servers that are out there. Customers who didn't even have or thought they needed high availability or thought that it cost too much to have redundancy for their on-site file server, for example, and buy a cluster of NUCs. Our entry-level systems, the MSRP is around $5,000. I mean, it's pretty. These are pretty price competitive with what you'd buy even a low-end, fairly non-resilient server for. And then you also get remote manageability, rolling upgrades, a lot of things that you just don't get on a single box.
I think it's that stuff. It's the softer stuff that makes the difference at the edge, because the performance, there might be some fringe cases where you need it, or capacity needs or whatever, but you've talked about ways to address that. I'm just glad that you've productized it with a single name, because when we had a podcast with Kristen Brown from Intel's NUC team, and I had to ask her, like, can you break down the nomenclature?
Oh, yes,
because it's like NUC 7U513-264, and she's like, well, here's how it works.
That decoder ring.
Okay, well, it makes sense, but if you're not in that on a day-to-day, it's hard to suss out what those things all mean.
Yeah, and I expect there'll be different series. I mean, already in this line, we offer the i3, i5, i7, the different storage capacities, RAM, 64 gig down to 8 gig, and kind of logical things in between. This also met a need for simplification. We had to do some interesting things relative to our other platform for the networking. So, I always joke, it's like, I do think a gas station manager could figure out the Ethernet goes here and the power goes here.
It only fits one.
And there's two cables. And by the way, on productions, we actually block off some of the other ones. So it's and we've even gone as far as customers, if you want us to color code these lids for you, and cables, you can do all that stuff. But it's not like taking a machine out of a rack and doing these and by the way, if these fail anything, you just send. We never ask customers to open this thing up, and even though it's possible, if it's the bad NVMe burns out, send the whole thing back, replace a new one. So it's a very easy replacement experience.
You ship those out of Indy too, or those come from?
Those can come from different distribution centers. Yeah, they're generally hot shipped. We have an integrator that we work with, and have global access. But sometimes they come out of Indy.
Yeah. I mean, I think it's neat. I think there's some might be apprehensive to think about using systems like this, but the micro movement has been going on for so long. HPE's got their micro server. We talked about the Lenovo, not even just the Nanos, but their SE350, that half server. That's one of our favorite things in the world. And all of these micro things, and they normally come with some sort of compromise, though, right? Because you're condensing to a point. But you guys are getting good mileage out of this. Have you thought about, because there is the SATA bay in there, have you thought about using that for more capacity?
Yeah.
I don't know how useful that is for your setup.
It would be useful. There's some use cases. The 4 terabyte will help a lot. I mean, kind of looking at our product line, like from here, we go up to our HE500, which is either a rack mount or a tower unit, and definitely bigger. So from a capacity standpoint, we kind of do have a good... We haven't seen the use case very often where it's like, well, I really need this small real estate, or I just think it's small and cool, where they just go up to the HE500. It's based on the Lenovo SR250, so it's the half depth rack, also still low power. That, by the way, is one of the other things people really love about these is, they're low power. We do have customers that just use economy, almost home UPSs, $100 UPS systems.
We've got 4 running right
and
to the right
they'll run
of
for
us.
like hours.
So we've got 4 running to the right of us, and they're not. I can hear the fan. I don't know if it's getting picked up on the audio,
I'm
but they're
doing about
relatively.
4,000. I got a bunch of CPU burn stuff, and
Yes, we're actually using them while we're doing the pod, and so it's actually. Let's see if this works. I'll flip over to. It looks like that. We didn't turn that on. We're gonna use that for the live stream. I was gonna try to show you the live feed of the blinky lights, but they're quiet. We're running it on that Eaton fanless UPS, which is great. So you can put this in, that back office at a retailer where everything else is, right? And it's not going to add any noise, much noise or much heat or much power draw, which is all.
Yeah, they're definitely obviously intended for ambient air and so forth. So
yeah. Well, this is awesome. I want to keep talking to you, but I want to see this thing working. So I think we should kill this part of our podcast in half an hour. Well, this is going to be backwards because this comes out on Friday. But for those of you that are hearing the podcast, just know that if you go to YouTube, we'll have the live stream there all packaged up, so you can check out the demo that we're about to do and have live Q&A and all sorts of that. We've got a prize that, well, I guess if you're watching it on Friday, you missed the prize, but whatever, it'll be a good time. So check that out on YouTube. And Dave, thanks for joining in.
Yeah, thanks for having me.
Cool.